We said that there is not much new with this arrays chapter number 5. I have only told you about the range for loops for C++ 11 and afterwards. Later they made some additions or they modifications to range for loops in C++ 17 and 21. We are not going to talk about them. You would read it yourself. So one thing that we do most often is sending arrays to functions. As you know, we cannot send arrays to functions as they are. We send only the starting address. In fact, as we said before, when you declare something like this, int a something, okay, a is just an integer pointer that points to the beginning of the address, beginning of the array itself. So when you send something to a function, you are sending a pointer. That's it, okay? You are sending a pointer. Let's look at this code. I think we looked at this once, but it is okay if we look at it once more. Let's say I have an integer array of size 10, and I have these numbers in it. And for some reason that I want to get into, okay, for the I don't want to get into the details of it. This statement works. I mean, you might wonder. I mean, if a is just a pointer, how come this for loop knows the size of this array? Okay, it works somehow. If you are in the same scope of the declaration of the array, this is really an array, and C++ or C can figure out the size of the array, okay, this a. But as soon as you send it to a function, you are just sending a pointer, so this will not work. You will get a compiler error for this statement, but no errors for this statement, okay? So this slide is not about range for loops. It is about what do we mean by this a, okay? So if you are sending your array to a function, you are sending a pointer to a function, that's it. So this for loop will not work. Range for loop will not work because range for loop cannot know the size of the array. So what am I going to do? I need to send the size of the array. This is like comma, integer size, etc. When you send it the size, then you need to write your proper or old-fashioned classical for loop. Integer x starts from 0 to size, okay, and see out all the elements of this array a, okay. So we are sending just a pointer. So if I see such a function in your homeworks or in your exams, I don't like it. Usually I don't give any points to that question, okay. This doesn't work, okay. This doesn't work. Even if you write something for that starts from 0 to 10, I said it compiles and works somehow. Well, it works because by coincidence it works because you have more than 10 elements in the array and etc. So this is a logical, this is a compiler error. But even if you use the other version of for, okay, you assume that you know the size. Oh, I know some people, they do this. That's even worse, okay. They do this. For int I from 0, I less than size of a and plus, and then plus I, and then C out a I. They say that this compiles and works beautifully. Well, I mean, it should compile, yeah. And if you are lucky, if you have enough number of integers inside your array A, it would print some number of the beginning of the array. Yeah, that's true. But this is not doing whatever you are thinking of. Okay, this is basically taking the size of an integer pointer, which is 8 bytes or 4 bytes depending on your architecture. Okay, so it says that I am going to run a loop from 0 to 8 all the time because it's taking a size of a pointer, integer pointer, not array. So this is definitely a big, okay, no. Okay. What did I say before? The fact that your code compiles and sometimes runs, almost runs, it runs so it's worth of a grade of DD or DC, doesn't mean that it's a good code. So if I see something like that, okay, I will not like it. So let me take this out from here and put it somewhere up. Oh, did I get the T? Okay. So let's look at some examples of functions taking arrays or functions returning arrays. Okay. So I have an example here. It is fill array. As we read the comments, did everybody sign the online attendance sheet? Everybody? Anybody having any problems? So nobody forgot. Nobody's having any technical problems. As I said before, nobody has to have a smartphone of worth 10,000 Turkish liras. If you are in this situation, just see me after the class in my office and etc. I am not forcing anybody to. Okay, good. I have a function fill array. Fill array takes an integer array. Okay, there is no difference between this and constant integer pointer a. It is exactly the same thing. I mean, I didn't have to say the constant. When I say constant integer pointer a, when I say, well, in that case, you cannot change. No, I shouldn't say that. Maybe. Okay, let's. Yeah, I am going to have a discussion about these constant stuff. Let's say for now, this is same as exactly or almost same as saying integer pointer a. Okay, integer pointer a, and I am sending an array. I am sending the number of elements that you can have in A. Okay, I am sending the size. Also, I am sending an integer by reference. You are going to fill in this array in this function. And from the keyboard, you will get all those numbers. And you are going to return the number in this reference number used. Okay, so this is how they designed the function, just to show off how these things work. Okay, the proper way to write such a function would have been this would return an integer, and that integer would have been the number used, how many integers I have entered this into this array. Okay, but they are returning a void and they are modifying this. I mean, my version is function returning an integer is much more readable than this. Okay, but the book writes it this way, and most of the time we write this kind of stuff just to show how it works. Okay, so fill array works that way. Compute average, it takes two parameters again. An integer, this time it doesn't say size, it says number used. So I don't have to compute the average of the whole array. Maybe I can compute the average of the first part of the array A, or the first 5 elements of the array A. And in our case, some part of the array A doesn't include meaningful numbers. That's why I say number used. Okay, calculate the first number used elements of the array, and show difference. Call this compute array average on this array, and then it shows the difference between the average and all the elements of the array. Okay. So this is our main function. Main function says max number of scores is here at the beginning. It is defined with a constant integer named constant definition. I don't like this line 4 because I don't like globals, but you might say that this is not a variable, this is a constant. Sometimes we use global constant, yes, true, but it would have been better if I take this number 4 into this position between 18 and 19, because that max number scores is used only inside this main function. There is no need for making it, there is no need to make it a global constant, okay? So I use it just 2 times and inside the main function, and I am not using it anywhere else. So what is our rule? Try to get the compiler produce error messages for you if you make a mistake, okay? So if it is my intention to use this max number of scores inside this main function, why am I making a global? I mean, if I make it a global, and if I by mistake, if I use that constant in some other function, the compiler will not give me an error message, okay? So always try to make your constants we say that don't use a global variable. That's one thing. The second thing is, even if you have to use a constant, if you wanted to make it global, just consider that, can I make this a local constant? Okay. So in this case, it could have been a local constant. Make it a local constant. I declare an array, max number of scores, number used, and I call this array fill array, and this will give me number used, and I will call this show difference. Okay. Our main function is very compact, just 10, 15 lines of code. Okay, maybe 10 lines of code. That's the rule of the thumb. Okay. Don't write very lengthy functions. If your function is more than 30 lines of C code, then you are doing some mistake. Okay, that function is too long. Okay, try to find the part of the function that can be made into a function, another function. Okay, because I mean, when I read this is easy. Main, okay, declares, fills the array, and shows the difference, right? I can understand what this main function does. And this fill array, if I go to this fill array like this one, okay, it takes numbers from the keyboard and puts into the array, and it just returns the number used like this. So they are easily understandable, easily readable, and maintainable functions. And the names are properly chosen, and I am fine, right? So always try to write these kind of functions. Don't write functions that are too long. Okay, this is fill array. It takes numbers from the keyboard and prints them, puts them into the array, and take this loop. The loop says that, okay, give me some integers. They have to be non-negative, and if you give me a negative number, okay, I will end this loop. By the way, you cannot enter integers. The number of integers you are going to enter will not be larger than size. Okay, because that's all I have. That's the maximum. And this is the compute average. Okay, compute average is, I did not like this statement here. It is 0. Double total 0. I don't like it. Okay, right. This. What's the difference? This is exactly the same. Yeah, it produces exactly the same assembly code. Yes, true. But this is the proper way of doing things. Okay. If it is double, initialize with a double. Then with the average, what do? We add all the numbers, okay, to total after initialization of it. Okay, if number use is greater than 0, because number use may not be greater than 0, it could be 0. If it is 0, then you are going to run into this problem. Okay, always be careful about this division. Division by 0 is a runtime error. Okay, your program will be terminated because it causes a trap, it causes a interrupt to your program, and that interrupt is, if you didn't handle it, will be handled by the operating system, and your program will be terminated. So be careful about it. So this number used is greater than 0. If it is 0, then this one says that I am terminating, or it says that I cannot calculate this. I cannot calculate the average of this array. I am printing an error message, and I am returning a 0, which I don't like. I don't like this logic here. Okay, Why I don't like it? I don't like it because compute average should not print anything to the screen. Okay, its name is compute average. I am expecting it to compute average of the array and return me a double. But sometimes it is printing some stupid stuff on the screen. I am not expecting it. Okay, I mean either I should carefully document this, saying that compute average does and this, which still I don't like, or we should do something else. The main reason I don't like this is, as a caller, as a programmer, when I call this compute average, okay, I expect it to give me an average, okay. This one says that sometimes I am going to print something on the screen, I am going to return 0. How do I know that? How do I know that the average of my array is not 0? Because for some arrays, the average might be 0, right? I have 10 zeros in it. If you take the average is 0, and this one is returning a 0. I would not know, as a programmer, I would not know that it run into a problem, because as a programmer, I don't see the screen, right? And what did I say before? Many times I won't have a screen if I am doing embedded programming, etc. Even if I have it, my user is going to see this error message. So that's not a good thing. So how would you design this function? Eliminate this one, but I have to handle this error too. How would you design it? Yes? Return a negative number might be a good solution. What if my average is a negative? Yeah, well, you are saying that since my integer is contains only positive integers, non-zero, non-negative integers, my average cannot be a negative. So maybe I could use it. Okay, that's one thing. But let's say I have an array that can contain any kind of integers, including negatives and positives. Then I have to figure out something else. And we are going to talk about it in chapter number 16, 17, 20, whatever. We are going to call it exceptions. Okay? Good. By the way, yeah, if I wanted to use this one, integer E1, A, and total plus assignment E1, would have been perfect if it worked, right? But it doesn't work, right? Because this is just an integer pointer. The compiler doesn't know the size of the array. Okay, good. So this is compute average, and show difference is something smart. It just goes, see, I am the one that calls the compute show difference, and I am writing this compute average. At line 60, I don't know if I got the correct average or I got an error message. If I got an error message on the screen, I don't know anything about it. I still continue printing this stuff. Okay? That's not going to look good. Okay? So if I return the negative number, then I would check it here, saying that if average is less than 0, then I wouldn't print any of these, and I would say that show difference doesn't show anything, or maybe terminate the program. By the way, our second solution would have been terminate the program, because this should not be happening, etc. Which is not a very good solution, but it's a better solution than this. Okay, it's a better solution than this. Okay, but these kind of, I mean, other than this error, compiler error, I didn't tell you anything about the hard language rules. This is a compiler and etc. Right? I am talking about always style, right? Write it this way so that people understand it. Write it this way so that it is easy to program, and etc. Learning a programming language is not learning the rules. It's like learning English is not learning the rules. Okay, they have been teaching us English language rules for the last 15 years of your life, right? And by learning the rules, you don't learn the English language. You learn the English language by using it, by speaking it, by listening to it, okay? And sometimes you don't have to follow the rules, as long as People understand what you are saying. As long as you communicate efficiently with other people, then you are okay most of the time. Programming languages are like that too, okay? If you do this kind of an error, well, this is not an error, compiler error. This is within the rules, but it looks funny. Nobody accepts it. Nobody uses it this way. So you won't be able to communicate with other programmers properly. They will criticize you, saying that the function that you wrote is against the traditions of this language or traditions of the programming. Okay, so good. So this is a simple, very simple program. Again, I didn't say anything new about it. We just criticized the. I don't like many programs of this book. Okay, so you might say, why don't you switch to a book that you like the program of? But it gives me lots of opportunities to talk about these kind of errors. Okay, I cannot teach you about the language the way I know about the language by looking at perfectly written code. Okay, this kind of stuff is very useful to help me to tell you about stuff that are important. Okay. Well, yeah, usually when you make a mistake, that's what we do as instructors. I did my mistake. No, I don't think so. I think it is, I mean, both of them are academicians. They didn't work as a software engineer or developer. Okay, so they think that the programs run this way. Yes. You mean this one? You are saying that if the number used is, oh, you do compute average, yeah. But I mean, when you call this compute average, if number used is 0, maybe you should not call compute average instead of getting there and calling it again. But that's a, I mean, whenever you get this number used, it's not a good thing. Maybe I should write main function that way. Where is, okay, fill array. Who calls the fill array? Main function? Okay. Maybe after number use obtained here, maybe I shouldn't call show difference. Okay. And if I don't do that, then I should be fine. And in the documentation of show difference, maybe I should say precondition, okay, number used should be greater than 0. Otherwise, I cannot guarantee a correct result out of this this function, okay? So I can kind of fix that. And just to make sure that everything is working fine, I would put an assert statement, okay? I would put an assert statement in compute average number used, and I would put an assert statement in the beginning of this function, show difference, so that number used is not greater than 0, so that I can catch that error before sending my final output to my customer. Okay, good. So did everybody sign the attendance sheet? I am guessing open Excel, and let me do the checking. I realize that if I don't check the signatures, people think that it is okay to sign for other people. If I read the names, and I love it, you guys go silent when open when I open this Excel sheet. Everybody's, my name is coming up. Yeah. Okay. Today is 11th, and today's hardworking. Okay. Anil, are you here? Okay, congratulations, you are the first today. Ahmet, is Ahmet here? Mehmet Kaya. Yes. Emre Oytun. Enes Akar, Abdullah Göktürk, Kamil Duru. Okay, good. Where is Rabia? Okay. Yeah, I am looking for you. I didn't say your name. I am just. I have to tell you something every day, okay? Don't change your seat. Good, thanks. I am going to skip this. I am going to skip the next one, fill array search. There is a function search, okay? Okay, let's read this to understand if a function is written in a proper way or not. Reading the header, trying to understand how it works, okay? Then making a judgment about if this function is a good function or not, okay? It says, okay, I'm going to take an integer array. How many elements inside that array is used? And what is my target? What am I looking for? And I am going to return what? Return the first index of such that A index is target. So it just returns an index. If it doesn't find it, it will return a -1. I like this function, okay? Without looking at the implementation at all, I like how it is. Designed. It has a minimal number of parameters, and it returns a proper integer, not doubles or anything like that. And if I think about it, it is easy to implement too. But we don't talk about the implementations, okay? We talk about the fill array before, so it's going to make a search. So it says, okay, declare size, then I get the fill array, declare size, I fill array from the keyboard, and etc. And in a do while loop, I get a target, I make a search. If the result is -1, then I didn't find it. Otherwise, I found it, and it is at the position result. Okay? So the search is this. That's it. In a while loop, if not found and index is less than a number used, I keep doing this. If this one is equal to this one, found is true, and otherwise index plus plus. Okay, good. So I liked it, is okay. The last thing in this chapter is a sort algorithm. It's going to sort a given array. This is the selection sort. What kind of sort algorithms do you guys know? What did they teach you? I'm not talking about you, I'm talking about the undergrads. What did they teach you? Sort algorithm? Bubble sort? Bubble sort is easiest to implement and easiest to remember. Remember bubbles or sinking sort. It's the same thing. This guy is doing selection sort. Selection sort works this way. Maybe you have implemented this too. You scan the whole array, okay? You find the smallest element. I found it is 2. I swap the values of the smallest element and the first element, okay? So what do I have now? I have a new problem in my hand, okay? Now I am going to, let's say this is an array of size 10, right? I found the smallest element in my array, 10. I found it and I put it in the beginning. Now 8 is here. Now I have exactly the same problem, but it is smaller, right? Now I am going to run the same algorithm on an array of 9. Do it again. Select the smallest one and swap it. And now I have a smaller problem. And do this 10 times or 9 times, then you end up sorting your whole array. That's called the selection sort. Okay, simple enough. Of course, I need 2 loops. One loop will say, okay, the first loop will say, okay, I am sorting the whole array. Now I am array of size 9, an array of size 8, and etc. The other one the other loop will look for the smallest one inside this array. Okay. So my loop is going to be two loops, right? The first loop will run from 0 to size, right? The second loop will run from, let me do this. This is not C or C++, I am just making up this language. So the first loop I will run from 0 to size. The second loop, J, inside loop, the inner loop, will run from what? From I to size, right? So how many times this statement here? Can you tell me how many times this statement is going to run? State 1. It is not size times size, right? It is what? How many times? In the first iteration of this outer loop, the inner loop will run size times. Then it's going to run size minus 1 times, then size minus 2. So what is your rule here? It is size times size minus 1 over 2, right? This many times. Plus 1, whatever. N times n plus 1, yeah, okay. But maybe it is minus 1 because the last element, we don't sort the one element arrays, right? It is already sorted. Okay. Something like that. So this is how many times you are going to, this is the way you measure your program complexities. Okay, you will say that, okay, this is running this many times. Okay, so it is in the order of n square. Okay, n is our numbers, order of n square. It is n square is something bad for a sorting algorithm. Better algorithms are order of n log n. There are no algorithms, sorting algorithms for the general case that runs faster than n log n. Okay, there is a theory about it. N square algorithms are the simpler ones, like this selection sort algorithm. Without going much into the details of the sorting, let's go to, okay, this one. Okay, nicely designed function sort takes an integer array with the size and it sorts it. That's it. Okay. And swap values, I am going to use swap values. That's good. Remember this one? It uses the references. And index of smallest is, oh, okay, this is a good function too. It says that I am going to take an array, okay, and I'm going to find the smallest element in that array starting from the start index up until the number used. So if your array is this, many elements in it, I am going to find the smallest one in it starting from the start index. And number used is here, right? So it is ignoring the part. So because I know that this part is already sorted. Okay? If your start index is 0, it is going to find the smallest one in here. So this sort function will continuously call, okay, index of smallest by changing the start index, and it will swap whatever returns with the beginning, the beginning of that last part of the array. Okay, so let's look at the sort function. Sort as this. Index of smallest is my local. From 0 to number used, minus 1 is there because, as I said, if I sorted the n minus 1 element in an array of size n, then the last one is already the largest one. Okay, so I find the index of smallest in a comma index number used. Number used always the same. Index changes from 0 to number used. When you find it, I just swap just those two values. Remember the figure that I showed you? A index with the index of smallest. That's the whole sorting algorithm, very compact, nicely written, understandable. Okay. And swap value is like that. We already know that. Call by reference stuff. And index of smallest is already, see, very compact definitions, very small, like 10 lines of code, and I understand what it is, and the name is nice. Index of smallest, it says, okay, my minimum is a start index. Index of minimum is the start index. I am going to scan this whole array starting from index plus 1. Okay, if what I see is less than minimum, then I am going to mark it. Okay. The rules that I told you before, write your functions short, make them meaningful, give them good names. They are all followed in this example. You might say that sometimes I run into problems that I cannot find a good name for my function. Okay, I like to name my function f1, f2, etc. That means that you don't have a good solution. Okay, your solution, your algorithm is not a good algorithm. Okay, maybe you are writing a prototype algorithm to test some stuff, but if you cannot come up with a nice name, English or Turkish, and if you cannot document your function as compact as, okay, this one, okay, then you are making some kind of a mistake. You designed your algorithm, you don't know what you are doing. Okay, so these are all nice, and I guess that's it, and that will be yeah. What? Which one? Okay, okay, good. So let's talk about a little bit more on the multidimensional arrays. As you know, I can have one-dimensional, two-dimensional, three-dimensional, five-dimensional, n-dimensional arrays in C, C++. No problem. If you declare a page, a variable named page, array named page, two-dimensional, okay, you are basically saying that I have a page, it contains 30 lines, and each line will have 100 characters. That's what I'm saying, right? Okay, so this is logical, it is intuitive, and I can do that. How do I address, how do I access each character one by one? This is what we are going to do. This is, you are saying that on my page, line number 1, character number 1. On my page, line number 0, character number 1, etc. Okay, so this is how the page works. Okay, this is how the multidimensional arrays work. And on my memory, this is how the things work. When you say I have such an array, two-dimensional array, so there are total of 3,000 characters inside this two-dimensional array. Sometimes we call them matrices. Okay, basically you do this. Don't see this part. Okay, this one says that, okay, I have an array of size 30. What are your array types? What are the types of your elements? Each element is an array of 100 characters. Okay, 30. So there are 30 rows and 100 each of them. 100 columns, you might think. Okay, and in my memory, since this is an array of size 30, each of my elements are 100 characters. So it's going to be 100, this 100, the first 100 characters will be my page 0. This is page 0. Page 0 is this. Okay, and then I have my page 1, and then this is the last one, is my page 29. These are all 100 characters. So when I say give me page 28, it gives you this address. On top of it, give me the 55th element in my page, line number 28. It's going to give you somewhere inside, something like that. Okay, so this is how it works. It is all contiguous in my memory, and basically, I mean, I could have treated it like 3,000 dimensional, 3,000 character array of size 3,000. Okay, I could have treated it that way too, but I like to access it in a two-dimensional way because this is how I structured my data structure, and C++ allows it. So I can, after this line, maybe I can write this. Maybe I can write this. A character pointer. Why don't I write it in a different place? But I don't have it. Okay, let me write it here. A character pointer. Okay. 1D page. Okay, and I can say just make this a character pointer casting and page. So this guy is now a pointer to the beginning of this two-dimensional array. Okay, and now I can do stuff like cout one-dimensional page 2171. It's going to give me whatever the character is at that position. What did I achieve? I don't think that I achieved anything, but I'm just showing you that whatever I am storing in my two-dimensional array is just a single-dimensional memory location. I mean, that's the rule, right? In our machines, the way they designed our machines in 1950s, okay, our memory is just one-dimensional data structure, starting from address 0 to some large number. And whatever I do in my computer, however it is complicated, doesn't matter. Everything has to be stored in this one-dimensional world, okay? So somehow it is either the task of the compiler or the task of you to convert it to a one-dimensional data structure. Good. Okay. So not much talk after that. Maybe, yeah. Well, okay, good. Yes.
It should be character. Can you come back?
You mean my code?
Can you say character pointer one-dimensional page equals page on?
I mean, without doing the typecasting.
Yeah.
In C you can, yeah. In C++, C++ is, I mean, C++ says that I am not like C. I am just more type sensitive. I enforce types and etc. Right? In C, pointer is a pointer. I can assign anything to anything, but usually in C++ and in C you should do this. You are telling whoever is reading this code that I know what I'm doing this on purpose. What?
Is it work in C++?
In C, you mean this one?
Without character.
No, it will. C++ will definitely give you a compiler error. Okay, the newer versions of C will do the same compiler error. Maybe some other version of C, the earlier version, maybe. The rule is this: if you are doing an assignment, okay, initialization, the left side and right side should be the same type, right? That's what we said. If it is not, then you do the typecasting. I mean, all pointers are the same. They are 64 bits. They are all the same. It is okay to assign one pointer to another one. I mean, a double pointer and a character pointer and a string pointer are exactly the same size. They are just pointing to some memory location. They are, I mean, the address, the postal address of Gebze Technical University is the same size as the postal address of my home. Okay? This is a very large campus, but its address is the same size as a small home in Gebze. It's like that. So the address is an address. So I can do this assignment without having to worry about would it fit in there. It is just two things and one thing. You don't have to worry about it. What you have to worry about it after this, it is your responsibility to read this properly. Yeah.
Could you do page +1 to access this elements in a linear fashion, like 1D?
Yeah, you can increment this one. When you say, if you have a loop, you will say for loop I from 0 to less than 3000 plus I. When you do this, C out, okay, dot 1 dp and maybe plus 1 dp.
No, can we do that without 1D, just with page?
But if you well, first of all, page is a constant. You cannot change it. It's an array name. Okay. So even if you increment it, when you increment page by 1, you will get this. Okay, you will get this, not the second element. You will get this because each page element is a 100-dimensional character array. Remember, incrementation of a pointer means that advance that pointer with the size of that array's element, right? So that array elements are 100 element characters. Okay, good. Some people are confused about pointers. What did I say? One-dimensional array is a single pointer, right? How about two-dimensional arrays? Are they pointers of pointers? I think I had a small figure drawn somewhere. Where is it? I think I did that. But later I didn't talk about it to you guys. Not this one. Yeah, okay. If you declare A like this 10, 10, it's going to give you 100 images contiguously. Okay? But if you have a PA pointer, integer pointer to integer pointer, okay, double pointers, okay, you will have a single pointer. PA has an address in this in my memory, and it points to an array. Each of those arrays, each of the elements of that array is another array. So my structure would be this, okay? So it is okay to say A25 gets the value of 7, or PA25 gets the value of 17. Of course, you are supposed to allocate stuff for this one. The allocation happens automatically for this array. It's nice. For this one, you have to do the allocation yourself, okay? So the picture for this one is this. Picture for this one is this in the memory, okay? So this is more complicated, but it has some other advantages, and we will see about those maybe later when we look at the pointers. Okay, good. Any questions? So if there are no questions, let me take some break. When we come back from the breaks, we are going to start a new chapter. Pencereyi açalım arkadaşlar ya. Dışarı çıkın, sizden geri gelin. Arkadaşlar pencereyi açabilir miyiz arkadan?
Arkadan açsın.
Valla da açılsın.
Vallahi doğru.
yaptın ya? Arabada mı?
Özgüvene bakın.
Oğlum ben hala da benim aklıma bir adam var.
O zaman yapacak.
Biz kişi sanıyoruz.
Oğlum. Gerçekten öyle yaptım ya.
Aynı reklam.
Abi pointer adam. Zıplayı bitecek. Pointer. Abi zıplayılar efsanedir ya. Adamların çekmediği kalmamış.
Adamın çok fazla. Yavrularım sınavları da
O Hindistan'dan bir de beyin göçü lazım. 10 tane babayı...
Amerika varken niye buraya
10
gelsin?
tane babayı gelse değil mi?
Ama Amerika var buraya niye gelsin adam? Adamın ne düzgün onların ekmeği yazmayı bu pointer buraya pointer yapıyor. Burası şuraya
İlgi
pointer
çekmiyor
yapıyor.
diyor.
Burası buna pointer ediyor.
O da ona pointer.
Bunun ilk elemanı şuraya. Oğlum Emre sen kalabilirsin buraya sen şaka mı? En kötü DD ile geçiyor adama bak. Geçmek değil ki oğlum o. DD geçme sayılmaz.
Oğlum yalnız bundan DD alırsam öteki DD'ler kurtarmayabilir.
Şey yaparım. 540 alıyor musun sen hala? O A ile geçer. 8 ateş akademik.
Şey yaparım. 35 hareketli var ya. 5'te de 2 tane daha seçmedim onları ağır çaktım.
Bunların her birinde çağrı yıldız koyuyor. Yo her bir yıldız yıldız, çar yıldız yıldız değil mi? Yo her çar yıldız. Evet, çar yıldız var. Çar yıldız. Bir yıldız varsa tek elek var. İki yıldız varsa bir elek. Ama oğlum bir dakika. Bir dakika. Bunun her biri string'e yapacak. Bir katman daha gidiyor oğlum. String array.
Öyle işte.
İşte bir katman daha gidiyor. Sen böyle böyle yapmışsın.
Şu çift PA. Şunu istiyorsun.
Ama her bir
Her
eleman
eleman bunu gösteriyor. Eleman ve eleman.
da çar yıldız. Ama bunun her bir çar yıldız yani
Ama hala hologram mı değil mi emin değilim.
oğlum Emre sen kalacaksın şimdi. Var ya.
Varsa hologram mı? Çok mu bak?
Aa elim içinden geçiyor. Al dur. Bir şey hissettim. Ben keklik. Oğlum Emre sen var ya çok acayip sağlıklı söylüyorsun. Sen beni şimdiden bırak hocam kendime. Yalnız çalışırsan kalırsın demiyorum. Çalışmayacağım diye düşünmüştüm. Oğlum dersi dinlemiyorum daha. Yani. Telefona bakıyorum. Lol. Yok. Artı iyi sordun ya. Farkı ne biliyor musun? Biliyorum farkında. Niye ödüyorum? Hayır. Daha verim. Bir atom daha bir atom daha verim. Neyi daha verim? Onu soruyorsan bilmiyormuşsun demek. Anlat. Artı eşit hocam. İ'nin değerini artı soruyor, sonra i'yi çağırıyor. Tamam. I artı operatör artı. Post plus. Post ekranı. i'nin değerinin bir arttırılmış kopyasını alıyor, bir yere saklıyor. Sonra i'nin kendisini çağırıyor. 2-3 işlem arttırıyor yani. 1 trilyon tane olduğunu varsa. Benim umurumda değil yani. Türkiye'deki hiçbir şirket Amazon falan da. Amazon'da çalışmıyor. Hepsi gidiyor falan da. Bilişimle alakalı şeyler de var. Adam öğreniyor. Oraya girebileceğim bunu. O zaman soracaklar. O zaman bu hangisi daha iyi? Hocam bu artı sağda olur mu? Ya bizim hoca diyor ya. Şey diyordu. Yeni gelen çocuklardı, kod yazıyordu, ben de yazıyordum. İkimiz de aynı. O daha kötü yazıyordu, ben daha iyi yazıyordum. Aynı iş yapıyorduk. 0-5 saniye, 0-6 saniye yapıyor. Aynen. Fark etmiyor. İşte ben otomatik. Ama işte ona çok para almıyor. Patron şeye bakar. Patron şeye bakar. Çalışıyor. Verimleri var. Embedded'la falan uğraşıyor. Embedded.
Veya karşı komşunun erkekler.
Kaykada bir şey.
Ne kaygıdan bizim evden.
Bu ne lan? Bu sinirle oldu. Oğlum sen nerede yaşıyorsun?
Oğlum dağda yaşaran mı? Dağ var.
Çocuğun evi lan bu.
Afrika'da ev dağ mı?
Askeri herhalde şurada.
Oraya çıktın mı hiç?
Çıktım.
Kamp yapın oğlum.
Müthiş lan bura. Şehrin tam göbeğinde.
O ışık ne adam?
Oğlum ayı mayı
Tayyip
yemiyor mu lan?
geldi.
Ayı mayı yemiyor mu?
Afyon kalesi oğlum bu. Ne ayısı.
Belli olmaz oğlum.
Ayı.
Lan bu şehrin göbeği lan bu.
Nemrut Dağı bu ama. Bak yüzü benziyor aslında. Şu gözleri var. Kaşlar.
Evet. Tam da bir şey göstermiş.
Ama onlar ayrı bir şey yap. Secure folder falan yap. Ne oldu?
Sen nereden harcadın onları? Para var mıydı sende? Var. Kriptodan falan mı? Kripto falan mı bozdun? Kenarda. Tamam.
Başkanı gelmeden önce böyle bir
Olay yeri gelemez.
Okay, let's start. Finally, finally, today we will start talking about classes, chapter number 6. Okay? What is he doing? He is going to, okay, you sit down. Instructor talking here means that you should stop talking, okay? We started the lecture. Okay, finally, chapter number 6, we will start talking about classes, which are the building blocks of any object-oriented programming language. Okay, without wasting any time, let's talk about it. We will start talking about structures first. You know about the structures. You might say that, what's up? I mean, why are we talking about suddenly structures? Structures and classes are very, very closely related. And arrays are structures are very, very closely related, and we will talk about that. And then we will go to classes, okay? Today, I am not going to tell you many new things in terms of language syntax, but idea-wise, it's going to be a whole another world, okay? So let's start. Structures are our second aggregate data type. Remember our first aggregate data type, it was the arrays. Arrays, they say that, okay, I'm going to declare 10 integers altogether, okay, it's aggregate. I'm going to call all of them like my array, etc. Structs, they do the same thing, but they say that I am going to declare one double, one integer, and one string, and I'm going to call all of them together a person, for example, okay? So it is another way of aggregating data, okay? It's called structure, and we already know about this from our C course. Let me directly show you a program from the book, okay? So this is a struct definition. This struct definition here, is it readable from backstage, guys? They have nothing to do with this class. They have their own word there. Okay. Can you read these slides? Okay. They don't care. Okay, so this one says that, okay, I'm defining a struct. This name is CD account, cash dividend account. It's a banking term. It's basically in Turkish it is hesap, vadeli hesap maybe. Okay, so if you have a bank account, banka hesabı, what do you have in vadeli hesap? You have the bakiye, balance, interest rate, faiz, and term vade. Okay, so if I keep these three numbers together, I can call it a CD account, version 1. Okay, so I defined it, so it's a type now. I can declare variables of type CD account v1 account. That's it. Okay, so it's like defining an integer, right? When you say, I am going to define a variable now. What is the type? It is integer. What is the name? J. Okay, that's it. I am going to define a variable now. What is the type? CD account v1. What is the name? Account. Okay, so as simple as this, I defined it. This is same as in C, but in C we used to say, remember, struct CD account v1 account, right? That was the case. In C++, we just omit this keyword here in the declaration. We just treat the CD account like a regular type, okay? Since it is treated like a regular type, I can write functions like that, okay? Get data, it will take a CD account v1 as a reference, and this is my parameter name. I mean, I could have written a function void f. This void function f will take a if I can find the ampersand sign, if I can find the ampersand sign, where is the ampersand sign? This, 4, no, maybe it is here, maybe there, here it is. Okay, this one. Okay, integer ampersand and let's say k. Okay, so I can define a function like that, line 13, function f takes an integer reference, but this one, its name is get data instead of f. Instead of taking an integer reference, it is taking a CD account v1 reference. So intention must be to modify the parameter, the account. So what does it say? Precondition the account balance and account user and okay. So post condition, sorry, not okay. Post condition is I am going to fill this in. I am going to fill this in with user entered data from the keyboard. That's what it says, from the keyboard. Yeah. Okay. And this is my main function. In my main function, I am saying that, okay, I have an integer j. Well, I don't have it. I think I made it up. I have an account, and I am going to get the data from the keyboard using this function. And I am going to do this simple interest calculation. Date fraction interest. Rate fraction is account.interest rate. Remember, we used to access the struct elements using the dot operator. Dot is an operator, okay? And it's is that binary operator or a unary operator? Is that a binary operator or a unary operator? It is binary, right? Why? Because it takes two parameters, okay? Left side and right side. So binary operator dot, it says, I am going to access the interest rate field or member, remember, inside my account. All of my account variables, see the account variables, they should have these three things in it, okay? I am going to access it and divide it by 100.0, and then I will divide this account term by 12, then I will multiply it with rate fraction, then I will multiply it with the account.balance, and I will put the balance back in. So it is calculating the interest and it is putting the interest back to the account.balance. And then I print the results out. That's it. That's the whole program. It's a very simple program that uses the structs. As I said before, I didn't introduce anything new. Only I said that in C++, we don't put the keyword struct at the beginning of the struct declarations. This is struct definition. I am defining the struct. Okay, this is struct definition. This is a struct declaration. Okay, that's it. So why are we talking about the structs all of a sudden? As I said, we are going to extend the idea of struct. We like this aggregation, okay? We like this aggregation. This is different from the arrays, okay? In the arrays, I aggregate the same typed elements together. I can say, give me 100, 200 integers. They all have to be integers, okay? With a struct, I can have different type members in my struct. A double, an integer, a string. I can put all of them inside the same struct. This is nice. In arrays, I used to use the index operator to access the elements, right? Index operator. Is index operator a binary operator or unary operator? When you say a square bracket 15, okay, is index operator a binary operator or unary? Yes. It's a binary, right? Why? Because you have to tell the array name first, and then the index that you like to access to. So it's a binary, like the dot operator. Okay, dot operator is used to, access the interest rate element of this account. Okay, if I had an array, I use a square bracket to access that element, index by index. Okay, so they are very similar. The only difference is one of them takes the same type elements in it. The other one takes any type of element, any types of element inside it, and as a result, I am using different access mechanisms to access the elements of a struct or array. Okay. Another nice example from the book. Okay, it says that I have another struct. Okay, it's date. Nice idea. To keep a date, what do you have? You have the month, day, and year, right? You say my month is January 1, day is 15, and year is 2020, for example. Okay, you keep three integers together, you are representing a date, a birth date, or the deadline for your homework, or your graduation date, and etc. Okay, so I keep this date for any date that I like, and I even can do stuff like this: date array 20, right? I have an array of dates. Okay, so I am using both aggregate types at the same time. In my memory, there will be 20 consecutive date variables, one after the other, and I can access each of them one by one. Okay, so date is like a, remember, I mean, if you get confused about the struct stuff, I mean, what are we declaring? Instead of date, put an integer in there. Okay, if integer works, then date works too. Okay, I can do that kind of stuff. Or even better, I can do this. Look at this one now. Okay, struct CD account. Remember CD account? Initial balance, interest rate, term, balance at maturity, and I have another one, line 19, a date maturity. It means the ne derler? Vade tarihi mi derler? Vade tarihi, vadesinin dolduğu tarih, date. Okay, so I can access, I can add a struct inside another struct, which makes it very powerful, very powerful. Okay, this technique is called composition. You compose one struct inside another one. It's called composition, and it's a very powerful object-oriented technique, composition. Okay, get CD data is going to be exactly the same, but it's going to be more detailed because now I have 1, 2, 3, 4, 5 elements to get. But inside the get CD data, there must be a get function for the date part of it, maturity. Okay, so for that one I have the get date. Let's see this get CD data. Get CD data, it says I'm going to get the account by reference. Okay, first get the initial balance, interest rate, term, and maturity. Where is the, oh, okay, get date. See, these are all C in, but for this one, I have get date. And I am sending the account maturity, which is of type date, to this function, and this function, it is exactly what it needs, a date parameter. And I get these. Okay, so this is just a reminder about structs, and C++ we have the structs, we can use the structs. It's okay. And what else? Did I miss anything? I think these are all nice. Okay, okay. So remember this one. I can, if I have a, okay, again the same thing, two integers I1 and I2, two account variables A1 and A2. Okay, so like I am declaring integers, I am declaring account variables. What can I do with the integers? I can do many things, like I can assign values to integers. I can use the plus operator, minus operator, and etc. Okay. With A1, what can I do? I can access the balance part of it. A1.balance gets the value of 7, right? Gets the value of 7. Or I can do the assignment. A1 gets the value of A2. Okay. I can do the assignment. But unfortunately, I can't do that yet. Okay. Cout stream insertion A1. It doesn't work because I didn't define this operator for this struct yet. Or I can't use this is equal to operator. Okay. A1 is equal to A2 doesn't work. This one works. Size of A1 is going to give me something. Also, this one works too. I can get the address of A1 and assign it to an CD account v1 pointer. Okay, then use the arrow pointer that we used to use for the structs. And it would have been nice if I can write things like this, right? If A1 is less than A2, then print A1 out. And I also like to do this, A2 plus A1, and I will assign the results to A1 back. These are not possible yet, but we will do it with the operator overloading chapter. Okay. Good. So basically, that's the whole thing about this accounts. Okay. That's the definition. Don't forget about this semicolon. This is important. It has a meaning. Okay, it has a meaning. The meaning is this. If I put a D1 in here and D2, that means that I have now two variables of type date, D1 and D2, and they are global variables, right? So it is same as this one is saying this one is same as, I can do it in the other way. Okay, I did that, then I put D1 comma D2. Okay, so this part is the same as the part above. Okay, so that semicolon means that I am done declaring my variables. That it means. If I don't include anything in here, that means that I defined my new struct date and I did not define any variables of it. Yeah.
In C, in this way, we give another name for that struct in order to recursively call itself inside.
Its name is date.
Yeah, but we can give a second name like you mentioned.
By a type def, you mean?
Probably yes.
Well, you don't need it in C++ because the date becomes a name for this new type. Yeah.
I think he's saying that can we use this type date inside the lines between lines 6 and 10?
You mean this new type?
Yeah.
Of course not, because the definition of date is not complete yet. Okay, and putting a date in another date is not meaningful because that would, I mean, the type should be it is okay to put a date inside a CD account, because when I say line 20, I know exactly how much memory this maturity will take inside the CD account. Exactly, I know it. But if you try to put a date inside this date, the definition of date is not complete. So what does the compiler reserve? I mean, as a space.
We could do it in C though.
You didn't say it. You put a pointer to it, not the object itself. No, you can do this. Date pointer dp. Okay, this is okay. This is just a pointer. What is the size of a pointer? It is just 8 bytes, 4 bytes, whatever. Okay, but if you say I am going to put a date in it. Okay, sorry, date. What is the size of date without finishing this date struct? I don't know, so you can't put it. Okay. It's like, can I put a CD account CD in here? No, you can't. Why? Because I don't know the definition of CD account yet. It will come later. Okay. Putting a date is exactly the same thing. And it is not intuitive either, because an object cannot contain itself, right? It can contain the pointer of it, but it cannot contain a copy of itself. Okay, good. So let's go to the slides, back to the slides. This one is important, as we said. This is at the end of the semester, when we start talking about Java. In Java, you don't put a semicolon at the end of the class definitions or the struct definitions, okay? That's one of the biggest differences between Java and C++, okay? That's a fundamental difference between Java and C++. Why we don't need a semicolon at the end of these definitions in Java. So remind me when we come to that position, okay? And we'll talk about it. Good, okay, declaring the structure variables like this one. Account is of type CD account v1. And in my memory, remember memory is like this, okay? Let's say I have a variable integer I, okay? I is here, and I can put integers in it, right? When you do this, I have a variable named account. Its name is account. And inside this account, there are three things. One of them is a double, which is the balance, right? A 8-byte balance. Then another one is, what was the name? Term and balance and interest rate and term. Okay, interest rate is another field of the or the member of the account, and the term is another one. Double integer. So it looks like 8 bytes and 4 bytes, maybe 20 bytes total. By the way, remember in C++ we said that if you are declaring an array, the elements has to be consecutive. They have to come one after the other. The compiler guarantees it. Compiler doesn't give you a guarantee that it will keep interest rate and term right after each other. It may put some space between them. It is up to the compiler or your compiler switches, depending on the optimization flags and etc. So don't assume that after balance comes the interest rate and etc. Okay, it might change from compiler to compiler. Compiler or the C language doesn't make such a promise. It might put, don't be surprised, okay, this is 8 bytes and 4 bytes, you might say, so total of 20 bytes. The size of account might be 24 bytes. It might choose to waste some memory locations to optimize your code for speed. Okay, good. How do I access the data members or the members of this account? Accounts.balance, account.interest, account.term. That's it. So this is just a regular double, okay? A regular integer. Those are called member variables, and they are parts of the variable account. I define them. Okay, we talked about this already. I am going to skip these parts. This one, don't forget, we will talk about it. Okay, I can do the structure assignments. Okay, let's look at this picture. I have a struct B, it has an integer I and string S, and I have two objects of it, or two variables of it, B1 and B2. I have another struct A, which is exactly the same, int I and string S, and I defined two A's on it, okay? Of course, I can assign this A1 and A2. B1 and B2 are okay, I assignment, but this is not okay, A1 assigned B1. Although they are defined exactly the same way, for compiler they are two different variables. They are two different types, struct A and struct B. Okay, so it will not let you directly assign. It will not. It will not let you. It will not allow you make a direct assignment between these two variables, A1 and B1. Yeah. You can. I mean, in C you are the ruler. You do whatever you want. Okay. If you see in C, you say that you are going to make this assignment. I am telling you, then by forcing it, yes, you could. I mean, even if it doesn't do it, you know where this lives, right? A1 lives. You know this one lives too. You know their sizes. Make a memory copy, and you do the assignment, right? But you should not, of course. And what you can do is different than what you should do. Okay? Good. We talked about this. Function argument, like a regular variable, like a regular integer, okay? Whatever I can do with a regular integer, I can do the same thing with the struct types, okay? I can pass them by value, by reference, or combination. So it is okay to have a CD account v1 as a call by value, okay? Call by reference, call by constant reference, okay? Or simulated call by reference through a pointer. I mean, just imagine that instead of all these words here, okay, you typed an integer. It is the same thing, okay? Of course, I mean, with the integers, there is a plus operator available, minus operator available, etc. Those operators are not available for the CD account v1 because they don't mean anything. Good, and I can initialize the structs like this, date, due date, like an array initialization. See, remember the array initialization? I can array an array like this, and I'm initializing a struct like that. To access the elements of an array, you use the index operator. Now we are using the dot operator. Okay, good. So just a simple reminder that I mean, I didn't see anything new in up to this slide number 13, other than to declare a date variable in C. We used to say struct date, due date, and etc. Now we are omitting this word. Okay. To declare a struct object struct variable, you just use its name. That's it. Okay. After this, let's start talking about classes. Okay. Classes say this, okay. I like these aggregate data types, arrays and structs, okay. I like to go further and add this. On top of our member data, I am going to add functions inside the structs, okay. I am going to add functions inside the structs. That way, my functions can work on that data. My functions can work on that data, and that will force me to write more compact, more understandable programs. You are saying that these are the data that are related to each other. Okay, you define the data, and then you are providing the functions that will work on that data. Okay, that will work on that data, and that's the fundamental rule of object-oriented programming. In object-oriented programming, you write classes. Classes are like simple structs that will include your data and the functions that will work on that data. Okay, that will be it. Here is an example. I did not implement this yet, but let's say I have a rational struct. You remember the rational numbers? Rasyonel sayılar. Okay. So can you guys turn your laptops off? Turn your computers off? Your computer. You have a computer, right? Turn it off. Everybody. Okay. Just if you are looking at the slides, just look at this one. Okay. So I have a rational. Of course, for the rational, I have this one, right? A over B. I need two integers. Okay, that's the meaning of rational, A and B. And I have a function print that will print my rational on the screen like A, B. Okay. Remember how I can initialize a struct like that? Okay. Struct rational R1 gets the value of 1, 2. It's 1 over 2. When I say R1.print, it will print 1 over 2 on the screen. Okay. I can add more functions like this one. R1.add. This add will take another rational and it will add this rational to this rational, and I will get the result as a rational and I will assign it to another rational. Okay. It looks like, of course, I don't have add in here, but I can add it. Okay. So this function add, it will take another rational. Of course, it will return what? It will return another rational. It will take a rational and it will return a rational. Okay. So this will be my new struct. Okay. This will be my new struct. The idea is this. Hold on. Idea is this. Put together your related data, okay, in a struct, and also put functions that will work on that struct variables. And we will call it a class now from now on. Okay. I mean, classes are no different than structs. The only difference is that you put functions inside your structs and you will call them classes. Okay. After that, you try to use your functions to manipulate that data. Okay. Data is inside the struct or class, and you use your functions to manipulate that data. Okay. So your new variables, okay, when I say rational R1 will include the data itself. Also, they have their own functions to work on that data. I did not write these functions yet, but I am going to write it in a few minutes. Okay, this is called maybe it will be an introduction, early introduction, encapsulation. It is one of the basic principles of object-oriented programming. You encapsulate your data and functions in the same capsule, maybe, okay? And you follow this rule all the time. You don't leave anything out, okay? You don't leave anything related in terms of data outside of your class. You don't need anything, any function that work on the data outside of your class. So everything about that data should belong to the class. So it should be complete. Remember our string class, when we say string S1 and its initial value will be maybe A, B, C. This S1, okay, is of type string. String is a class. Inside this string class, inside this S1, I keep this data. On top of it, I can do stuff like give me the length of the string. It calculates and it returns it to you. Or I can say stuff like S1 dot append, okay, to BC. I can append this data end of this one. Okay, this is the function. So all the functions that are related to the string are inside the string class. I don't need any other functions, okay? And if I like to know what kind of functions are available, I look at the documentation. Documentation is going to tell me. So the main thing, the most basic thing that we do with the object-oriented programming languages is to design such classes. Find design classes such as rational. Okay, define the variables that are needed for a rational. Also define the functions that will work on that data. Okay, this principle of encapsulation, putting together all the data and the related functions together, is called encapsulations, and we are going to strictly follow this rule. Okay, if all we do is put together data and related functions together in C++ or Java or in any object-oriented programming languages, then that means what? We don't need any global functions, right? Because global functions, they need the data from the parameter list. With the encapsulation, with this kind of stuff, okay, C print doesn't need any parameters because all the data it needs are here, A and B, right? You might say that add needs a parameter. Yeah. Well, the add is going to add this rational to this one. So it already has half of the data it needs. The rest can be passed from the parameter list. Okay. So as I said, I am not going to remember what I said. I am not going to introduce very big syntactic changes, new syntactic stuff. It is exactly the same as definition of structs. I am only saying that now we are going to put functions inside our structs. Okay, we are going to put functions in our structs, and we will call them classes. So syntax-wise, it is very simple, but idea-wise, it's a whole different world, and we will keep talking about this whole world for the rest of this semester. Okay, so from now on, our main purpose is designing classes that obeys the rules of object-oriented programming. Yeah.
Why is there struct still in C++ if there is classes?
Why?
Why do structs exist in C++?
For backwards compatibility. Okay. I mean, I like to use the structs the same way C uses them sometimes, but usually I don't use them. Okay. I have the classes. Okay. So this is how you do the class definition. I am declaring a class. Instead of struct, I am using this keyword class. Okay. I am using keyword class instead of okay. I am using this keyword class, day of year, and for now, let's ignore this keyword. Public is a keyword, C++ keyword. Let's ignore it. And in day of year is a little bit simpler than date. Remember date? In date, I had month and day and year. I don't have the year now, so I am saying it's just day of year. So the 20th date of 5th month, etc. And I have this output. Okay? So only three things: day, month, and output. And that's the whole class definition. Now I can define stuff like this: day of year, okay, what, new year day, okay. So how can I initialize new year? Okay, I'm going to initialize new year like this: 1 1, right? Month is 1 and day is 1. Or instead of doing this, maybe I can do, let's not do that. Okay, ny dot day is 1, ny dot month is 1. Okay, so I have a new variable. We don't call these variables anymore. They are called objects. This is the class, this is the object. We used to say this is the type, This is the variable, right, in C. Type, variable, class, object. Okay? That's the object-oriented way of talking about the things. Still, we are not going to call this integer at class. We are going to call it a type. Okay? For the fundamental types, there will be fundamental types are integers, characters, doubles, floats, booleans, and etc. Okay? So these are the types, these are the variables. This is class and this is an object. Okay? So I defined an object and I am initializing its members, data members, and function members. Now I am calling new year dot output. This will nicely print, okay, my new year data on the screen output. I can put as many functions as I like, doesn't matter. And if they are related, that will make my day of year class usable. Okay, let's see a real example. Okay, here it is. Okay, not okay. So day of year, I have two objects of day of year. Day of year today, day of year birthday. So today is this and birthday is this. Inside today object, I have month and day. Inside birthday object, I have month and day. Note that I don't have any space for the output functions inside my objects in memory. Output function, there is only one output function, and it works for all the objects of this class. When I call the output function, it will work either on this one or on this one, right? So depending on where you call it. When you say today.output, okay, it will work on these two variables, integers. When I say birthday.output, it will work on these two. Okay? So basically, let's go to the real program, this one. Okay, class day of, well, you don't know about those, but I am, well, okay, let me, now you know it. Okay, good. Day of year, it has month and day in it. It has input, it has output, and let's ignore these three for now. Let's look at the input and output, month and day. Okay, so main, say that I will have today and birthday as my objects. On today I will call input. On birthday I will call my input. Then I will call this output function. Okay, let's concentrate on these two functions for now, input and output. Okay, so that's it. But I didn't tell you how to implement these functions yet, and I'm going to show you right here. Let's look at the input first. It is maybe a little bit, where is my input? Well, I did not implement input, sorry. Let's look at output then. Okay, output is this. Okay, it says that, it's interesting. Okay, it's month. What is this month? I don't have any parameters named month. I don't have a global variable named month, right? I suddenly started using this variable named month. But remember where I have called this output. I called output on today, and today has month and day in it, right? So when this function says I'm going to switch on our month, okay, month means whatever object I am called on, okay, I am going to look at the month part of it. So if month is 1, then I am going to print out a January, it is 2 at the February, it is 3 March, right? So I am going to handle the month stuff like that, and then at the end I am going to handle the day, like print the day like that. Okay, good. So I don't think that I have the implementation for input, but writing the input would not have been that difficult. Let's write the input then. How do I write the input? Okay, day of year and input, and it's going to be a very simple one, actually. Okay, this one, yeah. Okay, cn, what am I gonna write? Cn, I don't have any parameters. I need to enter the month first, okay, right? What? Month, right? Cn month, and cn, what is the other one is day? But maybe I need to first tell the user that enter month and day as integers, right? Backslash, yeah. Okay, like maybe this end of line. I entered month and day, and that will be it. So very simple function. It looks very weird for a C programmer. What is month? What is day? I mean, are these globals? No, we don't use globals. Where they come from? Well, somebody has to call this input. Somebody has to call this input somewhere where, yeah, see today.input. It's going to work on the day and month part of the object named input. Yeah. Did I? Where are those? No, this is correct. Oh, no, yeah, that's you are right, yeah. So the data is going towards the, okay. Okay, good catch, thanks. Okay, so this is how you write the input, and output is there too. But as you see, there is another function that I have written. It says that equals. So how am I going to use this equals? Let's use the equals. Equals is, okay. If I call this today.equals birthday, if this one returns true, then I will say happy birthday. Otherwise, I will say happy on birthday. Okay? So equals work this way. It is a function of the class day of year, but it takes another object of day of year, and it compares these two. Obviously, it's going to return a Boolean. So equals returns a Boolean. It takes another day of year object as a reference, constant reference, and it returns a Boolean. Let's look at the implementation of it. Or maybe, I think I have written the, yeah, I don't want to show it to you, but I like to implement it myself. So first thing first, day of year and equals, right? So this is how you write, member functions of classes. You say, I am not writing a, we know that this is going to return a Boolean, right? I am not writing a global function named equals. You are saying that, okay, I am writing a function that belongs to the class day of year, and it's going to return a Boolean. And this time, different from the input, okay, this time it's going to take a parameter. The parameter is another day of year object. Okay, other object, okay, other day of year. Okay, then I will, oh, I am out of time. I think there is another lecture will be had here. Maybe I should stop here, but okay, before I go, okay, this is the implementation. Look at it. If my month is equal to other object's month, and if my day is equal to other object's day, then I will return true, otherwise I will return false. Kind of confusing. Okay, exercise for you. Tomorrow before you come to class, please get this header, okay? This is my class. Input, output equals less than, and next day. This next day is going to return the next day for you. So what is the next day for January 1st? It is January 2nd, right? What is the next day for January 31st? It is February 1st. So it should return a day of year object for the next day. Just, okay, take a picture of this or watch it from the video and try to implement all of these functions and use it in a program, okay? So that will be it for today.